Hello students, in the last video we discussed about the activity and the Fleming's left hand rule. So in that activity we have seen that a conductor, that is copper wire, it was placed between the two poles of horseshoe magnet and a current is passed through that wire. On passing current, the wire bends. It means a force is applied on the wire, and because of that wire bends. That we discussed in the last video. So Fleming's left hand rule, it relates the direction of current, the direction of magnetic field with the direction of force. We can get maximum force when the direction of current and the direction of magnetic field are perpendicular to each other. So after discussing that, now let us start the new topic, that is electric motor. Actually, the electric motor is the application of Fleming's left hand rule. So here the force is there, the force obtained after passing electric current when the conductor is placed in magnetic field, then that force acts on the different parts of the coil. A motor contains coil, so on that coil this force act, and then because of that we get the rotational motion of the coil. So let us see the definition of electric motor and the principle of the electric motor on which the working of electric motor is based. So electric motor is a device which converts electric energy into mechanical energy. So it is called as an electric motor. Electric motor works on principle that a current carrying conductor placed in a magnetic field experiences a force. So we have seen the last activity when that rod wire was kept, that time wire was bending either in C position or B position. So same principle is used here. So in case of motor, the force acts on the different parts of the coil of the motor, and which produces the rotational motion of the coil. So in the figure that motor is shown, that motor you might have seen at home to drive up the water in the over tank. So that motor is there, we can use for that principal base of that motor is, we can say it is a Fleming's left hand rule. So let us see the working construction and working of the electric motor. Now you can see the figure on the screen, or you can see, we can say in the in the textbook also. So there is a rectangular loop of copper wire with resistive coating, that is ABCD. It is kept in between the two poles of horseshoe magnet. So here this horseshoe magnet has a strong, we can say that the magnetic field. So that loop, we can say ABCD with resistive coating is there. It is kept in between the two poles of the horseshoe magnet. Then the ends of this, we can say that the loop is connected to two hulls X and Y. It is shown in the figure. So this, there is X and Y, these are the, we can say that the two hulls of the split ring. So these wires are there, two ends are there connected to X and Y of split ring, and the to the outer conducting surface of X and Y, they are connected with the, we can say, carbon brushes E and F respectively. So you can see the construction, very easy it is. After seeing the construction, now let us see the how it works, how this electric motor works. When the circuit is completed with the plug key or switch, the current flows in the direction E to A, then B, then C, then D and F. See carefully. When electric current pass through that, we can say that the coil, that or we can say loop, then the current flows in the direction E, A, B, C, D and F. As the magnetic field is directed from north pole to south pole, the force on AB is downward and the force on we can say CD is upward, according to we can say the Fleming's left hand rule. Hence, AB AB moves downward and CD moves upward. These forces are equal in magnitude and opposite in direction. Therefore, the as observed from the side AD, the loop ABCD and the axle starts rotating in anti-clockwise direction. After half rotation, X and Y comes in contact with brushes F and E respectively, and the current flows in the direction E, D, C, B, A, F. Hence, the force on the CD is downward and that of we can say force on AB is upward. Therefore, the loop and the axle continue to rotate in the anti-clockwise direction. After every half rotation, the current in the loop is reverse and the loop and the axle continue to rotate in anti-clockwise direction. When the current is switched off, the loop stops rotating after some time. It's a very easy, we can say, working one. Just you have to see the diagram very carefully. When the electric current pass, that time you can see that the loop is there. It starts rotating in anti-clockwise direction. After completing half rotation, again we can say that it rotates in the same anti-clockwise direction, but the force we can say acting on the first ACD first in the first case before half rotation, in the starting it is AB in the upward direction and AB in a downward direction and AB in the upward direction. After half rotation, the force on the CD is downward direction and on the AB is upward direction. But here the coil or whether we can say loop continues to move in the anti-clockwise direction. So after studying this, we can say that the construction and working of the electric motor. Now let us discuss about the applications of the electric motor. Now see the application of the we can say this electric motor. The application means we can say uses the use of the electric motor in the domestic appliances such as mixer, a blender, a refrigerator, a washing machine, all contains the we can say electric motor. Even in electric fan, hair dryer, a record player, a tape recorder and a blower, they also contain the we can say this electric motor. In an electric car, a rolling mill, an electric crane, an electric lift, a pump, a computer, and even an electric train. They all run on the electric motor. After studying this application, now you go through the video again and find out the answers of the given questions. That homework is displayed on the screen. So just go through the video again and write the answers of the questions which are asked as a homework. Okay, thank you.